Okay, this is your introduction to Unit 4, Polynomials. We are in Objective 4.1. This is going to be sort of a vocabulary lesson all about polynomials. So what is a polynomial? Polynomial comes from poly, meaning many, and nomial, in this case, meaning terms. So a polynomial says many terms. A polynomial can have one or more variable or constant combined by addition or subtraction. All exponents must be non-negative integers, no roots, no dividing by a variable. So let's go over some vocabulary here. These are going to be your parts of a polynomial. Terms. So the terms are the parts of a polynomial that are being added or subtracted. So we're going to underline each term here in this example. Terms are separated by addition and subtraction signs, so that's how you can kind of differentiate. So I have one term here, I have the next term here, so that plus sign is indicating that the 3 is positive, and my third term is negative 5. Again, that minus sign is indicating that 5 is negative. So there are 3 terms. Coefficients. If a term has a variable, the number in front of the variable is the coefficient. Each coefficient takes the sign in front of it, just like we talked about in the example in pink. If the coefficient is not written, it's an invisible 1. So we're going to circle the coefficients in these two polynomials. So we're not going to circle the whole term. We just want the coefficient. The coefficient of y squared is 3. The coefficient of y is positive 4. And then 8 is a constant. There is no variable with that term, so that is not considered a coefficient. That's a constant. We can circle 5. Negative 2. Now here, for x, it's invisible, so we can write a 1 there, positive 1. And then 7 is a constant. If a term has no variables, it is a constant. The constant takes the sign in front of it. So we're going to put a diamond around the constant in the term, or in the polynomial. So we're not looking at numbers that have letters with them. So in the first polynomial, negative 1 is the constant. In the second polynomial, positive 5 is the constant. Leading terms. The term with the highest exponent is known as the leading term. So it is not necessarily the term that is the first term in the polynomial. It's the term with the highest exponent in that entire polynomial. So we're going to look at our examples. The leading term is x squared because that has the highest exponent. It does happen to be the first one. In the second polynomial, the leading term is 2x cubed because it has the highest exponent. The leading coefficient is the coefficient of the leading term. So you're going to look for the leading term. which is the term with the highest exponent, and you're going to identify the coefficient of that term. So we're going to identify the leading coefficient. And that would be, for the top one, -1. And for the second one, it would be +7. That's find the term with the highest exponent and identify the coefficient. That is the leading coefficient. Okay, degree. If your polynomial only has one variable, the degree of the polynomial is the exponent of the leading term. So again, you're finding the highest exponent, and that is the degree. So this first one is the 4th degree. That's the highest exponent. And the next one, 5th degree. Now we are going to name these later in our notes, but identifying the degree is just finding the highest exponent. Standard form. Standard form of a polynomial, we are going to arrange the terms so the term with the highest exponent goes first. And then you're going to follow with the other terms with the exponents in decreasing order. Last term should always be the constant. So we're going to, kind of going back to one of the first lessons we did when we were identifying separate terms, I'm going to kind of just draw a little separation in front of each plus or minus sign, just so I can clearly see, okay, I have 3 terms. I see which ones are positive, which ones are negative. Now I'm going to rearrange them starting with the highest exponent. So a highest exponent would be 3, that's with the x, so x cubed will be my first term. The next highest exponent is x squared, so positive 3x squared is the next term. Now, if you just see x by itself, there is a 1 there. We don't ever write the 1, but it's there. So that would be the next one, which is -5x, and then I have the constant, which is -12. So now this polynomial is written in standard form. Looking at the next one, I'll go ahead and separate these, a line in front of each plus or minus sign. Starting with the highest exponent, I have 4x to the power of 6. Now 15, oh sorry, I'm not there yet. The exponent of 5 would be -x to the power of 5. The next one is power of 4, and that 15 is positive, so remember to put a plus sign there because you do have to separate the terms. Next we have -10x squared, and then the constant -2. Uh-oh. Now that polynomial is in standard form. So let's talk about naming the polynomials based on the number of terms and the degree. So again, the highest exponent is what determines the degree. These are all filled in for you already. A polynomial with 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial, and anything higher than 3 is just considered a polynomial. The degrees have names as well. So let's see how we can classify these and put those names together. So we're going to make a little chart here. And for each expression, we're going to rewrite it if necessary into standard form, decide what the degree is, decide the number of terms, and what the leading coefficient is. So looking at the first expression, that's just a single term, 2x. So there's really nothing we need to do to change standard form. It's only 1 term. so 2x. The number of terms, there are no plus or minus signs, so we know this is just one term. The degree, I talked about this earlier, if you only see x, there is a 1 there, so the degree is 1. And the leading coefficient is the only coefficient, and that would be 2. Moving on to the next expression, 3x minus 2x squared. We need to put this one in standard form, so I have to rearrange it so the highest exponent goes first. So in standard form, this would be negative 2x squared plus, because it's a positive 3, and you have to separate them with a plus or minus sign, negative 2x squared plus 3x. The degree, which is the highest exponent, is 2. There are 2 terms separated by a plus or minus sign, and the leading coefficient would be negative 2, because that's the coefficient of x squared. 2x cubed is a single term, so there's no rearranging needed, just one term. The degree is 3, and the leading coefficient is 2. 5 divided by x. Now this is a tricky one because these terms are not separated by a plus or minus sign. They are separated by a division. So that means this is not a polynomial. The next one, 9 plus x, is a polynomial. Rewriting in standard form, remember there's this invisible 1 here as the exponent, so we would put x first plus 9. There are 2 terms. The degree is 1, that's the exponent, and the leading coefficient, again, there's an invisible 1 in front of the x, so the leading coefficient is 1. So to rewrite the next one in standard form, we would put 3x to the power of 4 first, then 6x squared, then minus 2. There are 3 terms in that one. The degree is 4, and the leading coefficient would be 3, because 3 is in front of x to the power of 4. Rewriting the next one in standard form, we'd start with 4x cubed plus x squared plus x minus 8. There are 4 terms in that one. The degree is 3, and the leading coefficient is 4. The next one has parentheses. Now, we can't write this in standard form with parentheses, so we'll have to distribute. 3 times x cubed is 3x cubed, and 3 times 1 is positive 3. And that's now in standard form because the highest exponent is first, and there are no parentheses. So there are 2 terms in that one. The degree is 3, and the leading coefficient is also 3. All right, this next one looks a little different. It just has a fraction as a coefficient, which is fine. So none of the rules change. This is already written in standard form because the highest coefficient is first, and then it goes in, sorry, not the coefficient, the highest exponent is first, and it goes in descending order. There are 3 terms. The highest exponent is 4, and the leading coefficient is the 1/2. The next one, remember in the beginning it says there can't be any roots, so this again is not a polynomial. And the last one is a polynomial. It's a constant. It's already in standard form because there's only 1 term. The degree of a constant, if you refer back up to the chart, is 0. And the leading coefficient does not apply because there are no variables. So use this chart and these definitions for your practice assignment today.